Hello everyone. Welcome to Vijay Codes It. So first of all, I want to say sorry that I wasn't able to upload the videos regularly. I was having an interview with Uber, and due to that reason, I was busy in preparation for Uber. Now I'm done with that, so now I can focus thoroughly on the content creation. If you guys want that I should make like my interview experience with Uber, how was it? What questions were asked? You can drop a comment, and if like more people are requesting for it, I will be making a video on it. So that being said, in our previous video, we discussed how join works internally in Spark. So in today's video, we are going to see the join strategies. The three join strategies that are important in terms of interview perspective are shuffle, sort, merge join, shuffle has join, and broadcast has join. So these are the three strategies that we are going to discuss in today's video. Few interview questions that I can tell is you will be definitely asked what is difference between shuffle, sort, merge join, and shuffle has join. And broadcast has join is an important question in itself. So make sure that you are watching today's video with 100% attention. And if you're not able to understand, please watch video like more than once. And one genuine request, if you haven't subscribed to the channel yet, please consider subscribing. That gives me the motivation to create the quality content. So let's begin. First, let's see shuffle, sort, merge, join. So to understand shuffle, sort, merge, join thoroughly, let's take an example. Let's consider that we have two data frames, df1 and df2, and the IDs are like 1, 2, 10, 14, 3, 1, 4, 3, 12. We have seen how shuffling occurs in previous video, so we won't be discussing that in this video. To understand shuffling, I would highly recommend to watch our previous video. If you want, I can give the link of our previous video, that is how join works internally in Spark, in the description. So let's assume that after the shuffling, we have like these two partitions. And so what will happen when we do shuffle, sort, merge, join is Spark will be sorting out both the IDs. So after sorting out, we will be having two partitions of 1, 2, 3, 10, and 14, and 1, 3, 4, and 12. So what happens is Spark basically sorts out both the partitions and then matches the ID and performs the join. So the output would be 1, 3. That's it. So here the sorting takes place. So the time complexity for sorting is O of n log n, and this takes place in CPU. So the sorting takes place in CPU in shuffle, sort, merge, join. So this is what shuffle, sort, merge, join is. Now let's see what is shuffle hash join. Once again, let's take our two pretty data frames to understand it more thoroughly. 10, 12. Okay, so what will happen is, so once again, let's assume that we have these two df1, df2, or you can say these two partition. After the shuffle has taken place, so we are not understanding shuffle over here. Shuffle has been taught in previous video. So after shuffling, we have like this data. So what will happen is before merging, Spark will be converting the IDs of the smaller table into a hash and storing it into a hash set. So values 1, 5, 12, and 10 would be converted into hash. And then what Spark will be doing is it would be searching 1 in this hash set. If it is present, it would be merging those. And hence the output would be 1, 10, and 12. So over here, we are creating a hash set, and the lookup in hash set is basically O of 1. So it is faster than shuffle, sort, merge join as it is taking O of n log n for sorting, and we have O of 1 in shuffle hash join, and the time taken for shuffle would be equal for both of them. So then why do we even use shuffle sort merge join if we have like shuffle hash join which completes the task in O of 1? So the drawback over here is that the hashing takes place in memory. And this is one of the major drawback, because if the hash is like too big, we can get out of memory exception. And due to this, our whole pipeline can fail. And due to this reason, we use shuffle sort merge join or shuffle hash join when and where required. By default in Spark, it does this shuffle sort merge join. So if we have to change, we need to like indicate Spark that we want to use a different kind of join. So yeah, that's it. That's the difference between shuffle hash join and shuffle sort merge join. Shuffle hash join takes place in memory. You can see, and this takes place in CPU because the sorting takes place in CPU. And hash join, we calculate the hash of the columns on which we are joining. And in shuffle sort merge join, we sort the columns on which we are joining and then merge it. In shuffle hash join, we basically look into the hash and the IDs matched. Now let's see broadcast hash join. So to understand broadcast hash join, you must have watched our Spark architecture video where we have explained the concept of drivers and executors. So let's say this is our architecture as of now. We have one driver and three executors. So what was happening in shuffle sort merge join or shuffle hash join is we were basically shuffling the data. Let's say we had this two data frames. So we are shuffling the data across the executors to bring the common IDs together and then performing the join. We have seen in our narrow transformation versus wide transformation video that shuffle is a costly operation, and hence we should avoid as much of shuffle as possible. So that is the drawback that broadcast hash join overcomes. So what happens in broadcast hash join is, let's say we have two df1, df2. Let's assume that the size of df2 is 10 MB and size of df1 is 1 GB. So what will happen is the driver would be shipping this df2 to each of the executors. So let's draw df1 in yellow and df2 in white. So now what happens is, since the table 2 is way smaller in size, we can ship the df2 in each of the executors. Now we can directly perform the join over here because we have the data within the executors. We don't need to shuffle the data across the executors. And hence we have avoided the shuffling of data. So, so we can conclude that for broadcast join, we must have one smaller table. So now the question would be, what is a smaller table? So the answer would be, it really depends. It depends on what? It depends on the size of executor. Let's say our executor size is of 16 GB. So now, since the executor size is of 16 GB, our like smallest DF can be up to 1 GB. We can ship 1 GB of data frame in each of the executors to perform the join. So it really depends on how big our executor is. And on the basis of that, we have to judge if we ship data to the executors, we shouldn't be getting out of memory exception. This is the thing that we need to keep in consideration, that if we are and due to this reason, we don't apply broadcast hash join when both of the data frames are big in size. We only consider applying broadcast hash join if one of the data frame is way bigger and one of the data frame is smaller in size. Broadcast hash join helps us to avoid shuffling, and due to this reason, it's lower in cost. So in shuffle sort merge join, what happens is, let's say we have two data frame. We are reading both the data frames, and then Spark basically filters the data on the column which we are joining, so that it is not null. We have seen in our video that Spark basically optimizes the code for us. So this is kind of optimization provided by the Spark. You can see the video in our playlist in which we have taught the optimization about physical plan, how Spark creates a physical plan and chooses the best physical plan out of it. So once the Spark has done the filtering, it will be shuffling the data. Once shuffle has taken place, then it will be sorting it out. Shuffle, shuffle, sort, sort. Then it would be writing it. And then another job would be reading out of this and then merging it. This is how the shuffle sort merge join occurs. And in broadcast join, what will happen is we will be like reading both the data frames, read and read, filter, filter. And then instead of shuffling, we will broadcast, the driver will be broadcasting this table within the executors. So we have this data now available within all the executors. And hence then we directly do broadcast join and then the collect operation. So this is what is the difference between shuffle joins and broadcast joins. We understood the difference between shuffle hash join and shuffle sort merge join. We took a look what exactly is broadcast hash join, and we also like roughly drew out how the jobs stages would look like for both of the joins. That's it for today's video. If you are having like trouble understanding this video, you can leave comment and I will try my best to respond to those comments. Also, if you haven't subscribed to the channel, please consider subscribing. Thank you so much.